Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Jihan Fatina and today I'm gonna explain to you about this question. If the utility function is u equal to 4xy minus y quadrat and the budget equation is 2x plus y equal 6, determine the values of x and y that maximize u. So, the first one we need to find fxy. So, u equal with fxy. So u is 4xy minus y quadrat, and then we need to find gxy. From this equation we can make gxy. So gxy uh, 2x plus y equal 6. So if we want to find gxy, we need to make this equation equal with 0. So 2x plus y minus 6 equal with 0. So this is the gxy. And then, because we have fxy and gxy, we need to put this into this formula. F capital xy equal with fxy plus lambda g gxy. This, and then we put fxy here, 4xy minus y quadrat plus lambda gxy, 2x plus y minus 6. So this is 4xy minus y quadrat plus lambda times 2x lambda, lambda times y plus y lambda, lambda times minus 6 lambda. So this is for our fxy. Okay, because we find this equation, we can find the extreme value. So it's here. First step is we need to find extreme value. How to know extreme value? We can from this equation we should formulating with first partial derivative. So dou x dou f per dou x equal to, look at this equation. So if we want to find dou f per dou x, we need to close x. So for xy is 4y, and then from this we need to find x variable. So here 2x lambda, it means 2 lambda plus 2 lambda, and next dou f per dou y. So here for xy, because this is dou f dou y, so we need to close y. So this is dou for x, and then 2y minus 2y, and then plus y, and then plus lambda. And then next dou f per dou lambda. This is dou f per dou lambda can find with gxy. So this is same. So this is 2x plus y minus 6 equals 0. Oh yeah. the x we need to equal with 0. The first partial derivative we need to find with equal to 0. So we need to find lambda. So 2 lambda equal with 4 we need to move on the right side. So minus 4 So lambda is divided by 2. So we need to find lambda. So we need to make 2. This is 2 is gone. So we need to divide it by 2. So 2 divided by 2 is 1. And then minus 4y divided by 2 is 2 minus 2y. This is a first equation. And then this lambda, same guys. So lambda is minus 4x plus 2y. This is second equation. And for this is third equation. Okay, so after we find this, we need to elimination first equation and second equation. So lambda equal with lambda. So 2y equal with minus 4x plus 2y. Because I want to find x, so I want to put minus 4x in the left side. So 4x, 2y minus plus 2y. So 4x equal with 4y. X, 4 divided by 4 is 1. 4 divided by 4 is 1. So x equal to y. So this is the fourth equation. And after that, we need to substitute the third equation. 2, 3 equation. So 2x plus y minus 6 equal with 0. We have x equal with y, so we substitute x with y. 2y plus y. Make this constant to here. Make this minus 6 into plus 6. So 3y equal with 6. Y is 2. And after we find y, we need to substitute again for fourth equation. So substitute for equation. X equal with y. Y is 2, so x max is 2. So xy is 2.2. Okay, after we find this, we need to next to the next step, second step. Hold on. Xy is 2.2. Okay, so the next step we need to find second derivative for now. This has maximum or minimum. So second max or min. For this we need to second derivative. So sorry. 2 quadrat f or 2x quadrat. Look at here, we need 2 second derivative for for this first derivative. So dou quadrat f per dou x quadrat, look at here, where's the x variable? Because there's no x variable, so give 0. And then dou quadrat f per dou y quadrat, they have y variable, it means minus 2. And then dou quadrat f dou x dou y. It means dou quadrat f per dou x dou y, it means we look at dou f per dou y, and then we need to find, derivative the x. So look at here, this is x variable, so it's 4, and then we need to find dou g per dou x. Look at here, in this equation, x variable only 2, and dou g per dou y, only 1. Okay, after this we can move to the next step. It means Hessesian determinant. Erase this. So the third is Hessesian determinant. The formula is 2 gx gy fxy minus gy quadrat times fxx minus gx quadrat fxy. Here this is the formula, and then we need to substitute this into this formula. So 2 gx, look at here, gx is 2, gy is 1, fxy is this 4 minus gy quadrat. Gy quadrat is 1 quadrat, fxx is 0, gx quadrat 2 quadrat, fxy is 4. Sorry. I mean fyy. So fyy is minus 2. Kind of like this. So 2 times 1 times 4 is 8. 0. 2 quadrat times minus 2. 4 times minus 2 is minus 8. So this is from minus 8. So 16 plus 8 equal with 24. So Hessian determinant, if Hessian determinant more than 0, then the utility function is relative maximum. But if Hessian determinant is less than 0, it means relative minimum. Because this is 24 more than 0, it means maximum. So the utility maximizing value are xy equal with 2, x is 2 and y is 2. Okay, I think that's all. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. My name is Anissa Farismisha Indah, and today I want to explain to you about the question of the following page 47 in number 7. If known by each function of the following two types of products, x and y. So here we have two functions. The first one is qx. Qx equals with 18 minus 3px plus 2py. And the second function is qy equals with 3 plus px minus py. So the first one, we need to determine the four-partial margin of how to do it. Here I will show you how to do it. The first one, we need to find the first derivative of qx over px. So in here, we only look at the qx and we look at the px, the derivative of the px. So we only need to derivative the px. It's minus 3. The next one is the same thing as this, but it's dou qy over dou py. In here, it's minus 1. The next one is we need to find the cross-partial derivative. It's dou qx over with dou py. So how to do it? The dou qx, we need to find the derivative of dou py. So in here it's plus 2. The next one is dou qy over with dou px. We do the same things. We look to it here. It's 1 plus 1. So the next one is we need to determine is the product complementary or substitute or both. We can already tell from here cross-partial derivative. It's more than 0. So if it is the cross-partial derivative is more than 0, then the products will be substitute, or you can call it competitive. But if you want to make sure, we can use the other way. It's called cross elasticity. So in cross elasticity, we need to we have a formula in here. First one is EQX y. In here, we use this cross-partial derivative as our formula. Dou qx over with dou py times py over with qx. So here we can, from here it's 2, so we put it in here, and then py, we use the qx, we used the function before. The next one is we use the assumption to solve this. Py equals with 1, px equals with 1. We put it in 1, and then 18. We put the 1 in EX and also the 1 in EY. So it's 2 times 1, 18. And the final one is 0.118. It's bigger than 0. So it's still the same as before, except the product is substitute or competitive. From our answer, we can conclude that the X and Y product is substitute or competitive. It's the situation when the price goes up, but the quantity goes up and also goes down. So the next question is from Nicholas' book, page number 5. The question is, a computer firm has established the following total revenue or TR and total cost or TC. Functions for a computer is TR equals with minus 0.2 T quadrat plus 900 Q. TC equals with 0.03 Q cubic minus 0.2 Q quadrat plus 6,000, where Q represent the number of computers. So the first one, we need to find the corresponding marginal revenue and marginal cost function. Basically, the marginal revenue is the derivative of TR or TC. So the first one, we need to find the marginal revenue. Dou TR over dou Q, it will be 2 times minus 0.2 Q plus 900. So the marginal revenue is minus 0.4 Q plus 900. Now the next one is we need to find the marginal cost. The same thing as before, dou total cost over with dou Q in here. So it's 3 times with 0.03 Q quadrat minus 0.2 minus 2 times with 0.2 Q plus 6,000. The marginal cost will be 0.03 q quadrat and minus 0.4q. No, the 6,000 didn't include in here because they didn't have the q. So it will be 0 plus 0. So we didn't write it in here. So the next one, it will be used in here. So use the result of part A to find the quantity of. So in part B, we use the result of marginal revenue and also marginal cost to find the quantity of computer corresponding to maximum profit. So we use the equation marginal revenue equals with marginal cost. So it will be minus 0.4q plus 900 equals with 0.09q quadrat minus 0.4q. So we need to move this minus 0.4q to this side because they have the same variable. So it will be 900 because we move in here, so it will be plus. So 0.09q quadrat minus 0.4q plus 0.4q. Because it's minus means plus, so it will be 0. So in here it will be 900 equals with 0.09q quadrat. Now we can move the 0.09 to here. It will be 10,000. To remove the quadrat, we use square root. So it will be only q. So the quantity of the computers to corresponding maximum profit is 800 of computer unit. To maximize profit is 100 units of computer. The C1 we will find the price. The last one is point C. It's asking what is the maximum profit of this equation. So we can just put it, because we already know the Q1, the Q, so we can just put it in our function. It's minus 0.2 times with 100 quadrat plus 900 times with 100. It's equal with 88,000. The next one, we need to find the total cost. So total cost equals with 0.03 times 100 cubic minus 0.2 times 100 with quadrat plus 6,000. So here we will get 3,400. So because we asked for to search the profit. The formula for the profit is TR, or total revenue, minus with total cost. So 88,000 minus 3,400, it's equal with 84,600. So this is the maximum revenue. So here, so this is the maximum revenue. We can get is 84,600 monetary unit. Alright, that's all from me. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Miss, my name is Aiza Johara Jukriya with NIM 1040124400029, and today I'm going to solve column E, halaman 94, number 24. So the given utility function is 4xy minus y squared and 2x plus 5y equals 11. So we have to determine the values of x and y. So the Lagrange function is fxy plus lambda gxy. Okay, so first we have to put this into this equation here. Derivative of this. So for f, let x equals to 4y plus 2 lambda. You can put it as equation 1. And then the next one is for f of y, which is 4x minus 2y plus 5. And this is equation 2. Oh, and this one can be written as lambda equals 2y. Well, this one can be written as 5 lambda equals minus 4x plus 2y. And then after that, we can substitute the first equation, this one, into the second equation.
this. Second derivative of x is 0, and then the second derivative for y is -2. The second derivative for the x and the y is 4. And then the g, the x would equals to 2. The g, the y would equal to 5. And after that, we have to find the Hessian determinant. So the equation for Hessian is 2gx gy times fx of y minus gy squared minus fx gx squared times y1. And that means that it is a maximum because it's bigger than 0. So the utility maximizing values of x and y is equals to x with x equals to 3 and y equals to 1. Okay, so for this one, it's calling me on page 61, number 21. So given z equals to 2x squared plus y squared minus 4x minus 2y plus 80. And then the constraint is x plus y equals 5, which can be written as x plus y minus 5 plus 0. So you need to determine the extreme value, create a Lagrange function, and find optimal values of x and y and lambda. So the first step is to read it as a Lagrange function. So it would be the Lagrange function would be 2x squared plus y squared minus 4x minus 2y plus 80 minus lambda x lambda y and plus 5 lambda. the first derivative. So log x would give 4x minus 4 minus 1. That would be equation 1. And then dot f dot y would give you 2y minus 2 minus 1. That would be equation 2. Then dot f dot lambda would give minus x plus y minus 5. Or it can be written as the original constraint, which is x plus y minus 5 equals to 0. And then we need to put it into an equation. So lambda equals to lambda, and then 4x minus 4 equals to 2y minus 2. And we put it in the same terms. So 4x minus 2y equals to minus 2 plus 4, which gives you 4x minus 2y equals to 2. And with the equation. X plus y equals to 5. So we need to turn this around, which then gives you 2y. 5 minus x, so you put on y. So 4x minus 2, 5 minus x equals to 2. And then 4x minus 10 plus 2x equals to 2. Then that will give you 6x squared equals to 12. So x will equal to 2. And then we can find y now. So since y is equals to 5 minus x, that would be plus 5 minus 2. So y equals to 3. The coordinate will be 2. So to determine the if it's minimum or maximum, we need to use the Hessian determinant. Find the second derivative of this. So x squared equal to 4. It would be 2 brackets minus 1 times 1 times 0. This means 4 times times 1 squared times 2. That would equal to 6, which tells us that minus 6 is less than 0, so it's a minimum. And then the conclusion is that the values of the optimal values of x and y is is 2 and 3, where x is 2 and y equals 3.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So my name is Alfas Mefri Pertama, and I was assigned to do the Kalangi halaman 61 number 1, and then Nicholson number 6. So I will do the Kalangi first. So given the question is z equals 40x plus 25 minus 4x squared minus y squared. So we will try to find the critical value, the stationary, and then the maximum point. So first we will find the critical value first. So dou z per dou x equals 40 minus 8x. Second derivative dou z per dou y equals 20 minus 2y. So this is the first derivative. So we will find the second step is by square z per dou x square equals 8, which is bigger than 0, because 0 is the bare minimum for the stationary. Then dou square z per dou square y equals 2. So this is the x point, and then this is the y point. Since both of these point is it's minus. So since both of this point is smaller than 0, so both of them have the value of 0. So I will make it 0, and then dou z per dou y x equals to 0. So then to find the maximum point, we will use zero equal by 60 8. Since 16 is bigger than 0, so the point local maximum of f(x), x, and f(y), is smaller than 0. Or this is the local maximum. The next one, I will do the question number 6 for the question Nicholson. Given the total revenue plus so this the Q1 here annotates the shirt. So the question is, a factory have a shirt manufacturer, so how can they produce the maximum point when maximizing quantity of the production? And what is the profit at Q? If Q is 2000, what is the maximum amount of profit that this firm could earn? So we'll answer the first question. Is 2000 shirts. So this is the first question. Since the manufacturer only made the shirt for 2000 shirts a month. So X the total revenue minus total cost, it will be minus 0.002Q square plus 2 and minus 0. So this is the first equation that we will make, and we have to simplify this first. So this, we have to simplify this. We will break the down. Square plus 1.5Q minus 3000. Okay. So this is the simplified version for the first question. I will just scan on here. So we must find, is the profit maximizing, is the 2000 shirts is the profit maximizing quantity. We will find the derivative first. Is dx per dq equals minus 0.1q plus 1 equals 0. So we have to solve this. So Q here are 1.5 per 6. It will be 2050 shirts. So this means that 2000 shirts is not the maximizing profit for the manufacturer, for the factory. This instead is 2150. Since we use the derivative, and we also simplify the function between total revenue and total cost. So we move on to the next questions. Next question is, how much the profit are at if Q are 2000? Profit if Q are 2000. So we're still using the tortilla RTC function, of course. We just write it down. We also have to simplify this. 0. Square plus 20 equals minus 0.003. So This one is the equation from this become this, and then this become this. Okay. Since we also get that 40,000 plus 40,000 will become 28,000. This is the total revenue. If the manufacturer made 2,000 shirts a month, so the total cost is, we just copy from this, because Q here we change it into 2,000, so we put in the Q into 2,000. Change it. Here is the answer. Since this will be divided by 4 millions, so it will be so profit means that total revenue minus total cost. So 28,000 profit will be 28,000 minus 8,000 will be 20,000. So this is the profit for the manufacturer. And then we move on to the last questions. The last question is, what is the maximum profit that this manufacturer can make? Equation x minus 0.005 q plus 21.5 q minus 3,000. This is the definition from this combined. So this is the definition. So we substitute this q with this search earlier, like we get 2,150, which is the profit maximizing quantity. So it will become minus 2,150 plus 21.5. So 21.5 Q minus 3,000. Okay, so we calculate this. 650. Where 4,622,500 and then minus 0.005 minus 4,600,000 equals minus 23,112.5. Again. 5 times 2,050, 46.225. So x 50 equals minus 23,105 plus 46,025 minus 3,000. So the answer will be 30,100.5. So this will be the maximum profit the manufacturer can get, since we divide the maximizing profit and the total revenue and total cost. Thank you.
Okay, my name is Muhammad Kadar Wicaksono, and I'm from ICT 1. So in this video, I want to solve a question of Kalami number 2. Okay, so we given qx equal 5 minus 2px plus p and y and qy equal 6 plus px minus py. Okay, so the question is we have to find marginal and cross elasticity. Okay, so the A1 we have to find the marginal. So find the partial derivative of qx and qy with respect to both px and qy. So dou qx over dou px equal to minus 2, and then dou qx over dou px, and then equal to minus 1. So the qy1 is dou qy equal to 1, and then over the dou px, and then dou qy over dou py and equal minus 1. Okay, so this is the answer. And then B, what is the relationship between the two products? So the first one is partial effect qy on q is dou qx over dou py equal to 1, and then the result is substitution py to up, and then the qx also goes to up. Same like the first one, the dou qy over dou px equal to 1, and then this substitution px goes up, and then qy. So this is the utility function is u equal to 8 plus 7 xy minus 2y squared. Then the budget constraint is x plus 3y equal 8. Then so the answer is this fxy equal 8 plus 7xy minus 2y squared plus lambda and bracket 8 minus x minus 3y. Okay, then we find the partial. So dou f per dou x equal 7y minus lambda equal to 0. Second one, dou f over dou 7x minus 4y minus 3. And the third one is so dou f per dou y equal to 8 minus x minus 3y. So y equal to 0. Then dissolve the system. Equal with 7y, and then we substitute 5 into 3 like this. 8 minus x minus 3y equal to 0, and then it's like this. X equal to 8 minus 3y. Then we substitute oh, I forgot. Before this, we have to substitute the 4 into 3, like this. 7x minus 4y minus 3 bracket 7y equal to 0, and then result is like this. 7x minus 4y minus 21y equal to 0. Then after this, we have to substitute 6 into 3. Okay. Oh, I mean 6 into 5. 7 bracket 8 minus 3y equal to 25. Y equal, oh no, the result is 56 minus 21y. Then equal 25y. So 56 minus equal with 46y. Then y equal 28 over 23. So this is the answer of the y one. And then we have to substitute y equal 28 over 23 into 6, like this. X equal to 8 minus 28 over 23 with 8 minus 4 over 23. So equal with 104 minus 84 over 23. So the answer is 20 over 23. This is for the x. So the final answer is the x is 20 over 23 and the y is 28 over 23. Okay, so that's all from me, and thank you. Assalamualaikum warahmatullahi wabarakatuh.